Okay, this is 3.3a of geometry. So when you have a theorem, right, it's if something then this. So our converse, or our corresponding angles theorem, said if two lines are parallel, then corresponding angles are congruent. The converse is when we switch the if and the then. So the corresponding angles theorem said if the lines are parallel, then angles are congruent. Now our converse of the corresponding angle theorem says if corresponding angles are congruent, then the lines are parallel. And again, you don't really need that paragraph there. So, if we look at this picture here, I am told that angle 1 is congruent, that's pretty big. Angle 1 is congruent to angle 2. And I want to know which lines are parallel. To figure this out, I would just draw the lines that I need. So I need this line, this line, and this line to form those angles. This guy here does not matter to me. So I would sketch it out myself. There's angle 1 and there's angle 2. Now it makes it easier for me to look at. So looking at this, I can see that these are corresponding angles. This one is above and to the right, and this one is above and to the right. So I know, this is line A and B, I know that A is parallel to B because of the converse to corresponding angles theorem. And you can abbreviate that if you want. Okay, so what if I was told that angle 6 was parallel to angle 7? Okay, well I'm going to draw my lines in again. There's line B, there's line L, there's line M. Here's my angle 7 and my angle 6. So, again, I can see these are corresponding angles. And the two lines that are parallel is L is parallel to M. You're going to choose the two lines that are going the same direction. These guys are just going the same direction, so they must be the parallel lines. So L is parallel to M, and again, that's by the converse to corresponding angles theorem. Okay, 3 more theorems. Again, you don't need those guys. If you really want to write them, you may. So, the converse of the alternate interior angles theorem says if alternate interior angles are congruent, so if A, I, A are congruent, then the lines are parallel. Converse of the same side interior angle postulate says if same side interior angles equal 180, then the lines are parallel. And the converse of the alternate exterior angle theorem says if alternate exterior angles are congruent, then the lines are parallel. Okay, here's a new kind of proof. We've done 2-column proof. Here's what we call a flow proof. There's arrows in between these that are hard to see a little bit there, but so we write out our statement and then we write the reason below it. And we're using these two guys to get me to the next step. So you line them up, whatever combines the next one. So I know that angle 4 is congruent to angle 6 because I was told that. I was given it. So given is written below it. And I know that angle 2 is congruent to angle 4 because they're vertical angles. Using those two things, I know that angle 2 is congruent to angle 4, which is congruent to angle 6, and I can get rid of the angle 4 in the middle. So I get angle 2 is congruent to angle 6 by the transitive property. Angle 2 and angle 6, if I look at my picture, are corresponding angles. So I know that L is parallel to M by the converse of corresponding angles, which is written out there. Okay, so let's try our own proof. We're going to use the picture from up top. I am told that the measure of angle 3 plus the measure of angle 6 is equal to 180. So, measure of angle 3 plus the measure of angle 6 equals 180, and that was given. what else do I know? If you don't know what to do with a proof, you can just start writing stuff down until you see how it combines, but I happen to know which one we want to do. So, the measure of angle 6 plus the measure of angle 7 is equal to 180, because that's the definition of a linear pair. Remember, a linear pair is two angles that combine to make a straight line. From those two, I get that the measure of angle 3 plus the measure of angle 6 is equal to the measure of angle 6 plus the measure of angle 7. That's by the transitive property. Because they're both equal to 180, I know they're equal to each other. And then I can subtract the measure of angle 6 from both sides so that I get the measure of angle 3 is equal to the measure of angle 7. That's by subtraction. So then I know that angle 3 is congruent to angle 7. That's definition of congruence. If two angle measures are equal, then they're congruent. And if I look at my picture, angle 3 and angle 7 are corresponding angles. So I know that L is parallel to M by the converse to corresponding angles. And there's your homework.